All right, let's get started. We're still looking at questions from reporting category number 1 from the Algebra 1 EOC for the state of Texas. And if you haven't watched the video from the 2017 version of the Algebra 1 EOC, I'm going to include a little link in the top right corner of your screen. That's a really good video to watch prior to this video. I'm going to go through all the questions from the 2018 version of the Algebra 1 EOC that pertain to reporting category number 1. And I'm going to go fairly quickly through the 2018 version. So, all right. Refer to that previous video for my little calculator tricks. I explained that at the beginning of the video. And I'm going to go down, just pardon my scrolling. I'm going to scroll all the way down. These are all the questions that we've already done from the 2017 version. And now we're at the 2018 version. So again, you need to watch that video from the 2017 version because I'm going to be talking about little tips and strategies that I've already talked about in that video. So this first problem, which expression is equivalent to, what's our trick for equivalent? When we see the word equivalent, we're going to store 2 in for the value of x. When I do that, I get negative 42 when I plug this into my calculator on my home screen. So the first thing I'm going to do is store in 2 for the value of x. And then I'm going to type in negative 28x squared plus 35x on my home screen, press enter, and I get negative 42. So then I'm going to go through each answer choice, F. When I plug in 7x times 4x plus 5, I get, what do I get? 182. Well, that's not negative 42, so that's not it. When I go to G and I plug in negative 7x times 4x minus 5, I do get negative 42, which means G is my answer. And if I were to go down and plug in H, I would get 42. And if I plugged in J, I would get negative 182. And since none of those equal negative 42, then that's not my answer. Now, if you're looking to actually solve this algebraically, you're going to factor out a GCF, which happens to be negative 7x. Factoring out a GCF means I divide. Let me see if I should erase this. I'm going to divide everything by negative 7x. Every term gets divided by negative 7x, and I'm left with 4x minus 5. So that's a factoring problem. Moving on, number 6. And this little box over here tells you the TEK that it's referring to. It really kind of helps teachers out. It doesn't really mean anything to students. So number 6, which expression is equivalent to? Well, there we go. We have another equivalent problem. In my problem, I have 2 different variables. I have a K and I have an R. So let's plug in or store in 2 for the value of K, and let's store in 3 for the value of R. One of the things we don't want to store is 1, okay, because there's just some problems where it doesn't really work out. So let's store in 2 or 3 or any other number, but just keep that stored in for that variable. So we're going to store in those values for K and R, and then we're just going to type in exactly what you see, open parentheses, 144 times K squared times R to the 14th, close parentheses, raised to the power of 1 over 2. If you need help with how to plug that into your TI-84, again, I would refer to that previous video because I talk about that. So when you plug that in, you get 52,488. So then when you go through your answer choices and you plug in each one, you're looking for the one that's equivalent to this. So you're looking for the one that gives you the same value of 52,488, and it's actually F, 52,488. So that's really the good test-taking strategy. Now, let's say you actually want to solve this algebraically. A good place to start is everything in this parentheses gets raised to the power of 1 over 2. So I like to start with my number. 144 raised to the power of 1 over 2 is the same thing as the square root of 144. Power over root. Power of 1, root of 2, which is 12. So automatically you could eliminate G and H. And then what do I do when I'm simplifying a power, like this 2, raised to another power? I use my power rule, which means I multiply my exponents. So if I look at k squared raised to the power of 1/2, well, 2 times 1/2 is 1. So k to the power of 1, which I don't need that 1 there, but I'm going to write it there. And then looking at r to the 14th raised to the power of 1/2, 14 times 1/2 is 7, which gives you f. All right, let's move on to number 9. In a sequence, oh, I love these questions. There's never too many of them, but in a sequence of numbers, these always confuse students. A sub 3 is 0, A sub 4 is 6, so on and so forth. Based on this information, which equation can be used to find the nth term in the sequence A sub n? Okay, here's your test-taking strategy. Here's your test-taking strategy. Make a table. What are we given? What are we looking at? All right, so if I'm looking at, obviously in my answer choices, I have an n and I have an a sub n. So let's let n be like our x values that you're probably used to seeing, and a sub n be our y values that you're used to seeing. And let's just make a little table. So in this first one, when n is 3, and remember, if it's a sub n, like I'm going to circle this n right here, a sub n, and then in this first like set of numbers that it gives us, this is a 3. That means when n is 3. Okay, so I'm going to switch numbers or colors here. When n is 3, a sub n is 0. Okay, and looking at the next one, when n is 4, a sub n is 6, and then the next one, 5 and 12 and 6 and 18 and 7 and 24, and make a table of values. Your test-taking strategy, when you ever see a table of values, plug it into stat calc. So you're going to do stat, edit, and then stat, calc, linear regression, linreg. Okay, that's a really good test-taking strategy. And then it'll give you, it'll say in the form of ax plus b, and then it'll say a equals 6, and b, oh, it won't let me do that, b equals negative 18, and so your answer would be C. But you can also go through, what I would suggest doing is, if ever in your problem or in your answer choices, you're given an equation of like a sub n equals, that's fancy schmancy for y equals negative 6 times x plus 18. So plug that into y equals. Anytime you see y equals, plug it into y equals. That's a really good starting point. So y equals negative 6x plus 18. Then second graph, that'll let you look at your table of values. Go through your table of values. Do you see these values in there? You don't. So not your answer choice. Do the same one for B. Y equals negative 18 times x plus 6. Second graph, look at your table of values. Do you see these? Nope. But when you plug in C into y equals 6x minus 18, you'll see this in your table of values. So go through your answer choices and look at your table. So you can kind of do either or. You can, obviously you need to make a table so that you can see what you're looking at. But then you could do this whole stat edit thing, which I have a lot of students that really feel comfortable with that. They like that strategy. Or you could go through your answer choices. And some of you it might just come to you and you might just see the pattern, which is great. All right, let's move on to number 11. Which expression is equivalent to? What do we do when we see the word equivalent? We store in 2 for the value of x. So store in 2 for the value of x. Then type in this into your home screen, and you get negative 90. When you go through your answer choices, A is what also will give you negative 90. So this is a factoring issue. When I need 2 numbers that multiply to negative 60 that have a sum of negative 17, and those numbers are negative 20, so x minus 20, and positive 3, so x plus 3. Negative 20 times 3 is negative 60. Negative 20 plus 3 is negative 17. That's one of those basic trinomials is what I like to call them. You could also, if you want, go through your answer choices and FOIL, right? If I FOIL x minus 20 times x plus 3, I'll get x squared minus 17x minus 60. So you can do any one of those things. Students that really feel comfortable with factoring just prefer to factor. Students that really prefer foiling. And then students who really like this trick right here, where you're storing in 2 for the value of x, they're going to stick with that. All right, number 20. We are rocking and rolling. Given f of x equals 1/3 times 4 minus x squared, what is the value of f of 16? What does this mean? What is it asking? It means, what is y when x is 16? There's always one of these questions on the EOC, and you have to get these right. These are the ones you have to get right. If you ever see f of x equals, that's fancy schmancy for y, equals, plug it into y equals. There's your test taking strategy. Then look at your table of values and go to where x is 16. What is y when x is 16? It's 48. All your calculator did, and your calculator just does it for you. It's finding f of 16 means I am plugging in 16 for x. Okay, so when I simplify this, I get 1/3 times negative 12 squared, which is 1/3 times 144, which is 48. So when you've got your grid like this on your Algebra 1 EOC, this is what it looks like. You always have a plus and a minus here. It's going to be positive, and just fill it in just like that. Positive 48. Okay, number 28. Which expression is equivalent to, again, love these, equivalent to, okay, well, we're given these q values. Q to the power of 4 raised to the power of negative 3 over q to the power of negative 15 for all values of q where the expression is defined. Woo, man. So this little part right here, students will probably struggle with that and wonder what the heck it's asking. It just means simplify this. Simplify this expression, which one is your answer. So if you really know your exponent rules, power to a power, and then your quotient rule, then you're probably pretty comfortable with this. But what I would suggest doing is store in 2 for the value of x and let the variable q become x in your calculator. X is just easier to plug in on your calculator. So you're going to plug in, open parentheses, x to the power of 4 raised to the power of negative 3 over x to the power of negative 15, and you're going to get 8. Then you go through your answer choices, which also gives you 8. H. That's your answer. Okay, but if you actually like to use your exponent rules, a power to a power, I multiply. I'm going to do that down here. So I'm going to get x to the power of negative 12 over x to the power of negative 15. And then when I apply my quotient rule, I'm going to subtract my exponents. Negative 12 minus negative 15. Okay, which is the same thing as negative 12 plus 15. And you get 3. So that simplifies as x to the power of 3, which I had changed our variable from q to x, so it's actually q to the power of 3. Okay, number 31. Which expression is a factor of? There is no trick here. You just have to know how to factor. Because I only have one factor, you can't, there's no trick, okay? Which expression is a factor of? So, and this is actually a really difficult one for a lot of students. I'm looking at this quadratic. It's quadratic because my highest exponent is a 2. How many terms? 1 term, 2 terms, 3 terms. That makes it a trinomial. So how do I factor a quadratic trinomial when this first value right here, or this a value, is not 1? I call it the slip and slide method or the slide and divide method. So what do I do here? I slip a into c and then I rewrite it. x squared plus 13x minus 420. So I'm looking for two numbers that multiply to negative 420 and add to 13. Oh my gosh. Super difficult. What are those numbers? 28 and negative 15, because 28 times negative 15 is negative 420. 28 plus negative 15 is 13. So I'm going to write those factors. X plus 28 times x minus 15. And I'm going to switch colors here. And then what number, because this is a slip and slide trinomial, what number did I multiply in? I multiplied 21 in. That's the number I divide out. So factoring a slip and slide trinomial, I do have a video over that too, and I'll put that link in the upper right corner of this video if you want to click on it. There's the lesson over factoring a slip and slide trinomial. So now you've got these fractions right here that we're going to simplify. And 28 over 21, I can divide by 7. So that's my common factor. So I get 4 over 3, and then I slide that in front. That becomes 3x plus 4. 15 over 21, I can also divide by 3, and I get 5 over 7. So I'm going to slide that in front. 7x minus 5. Which one of these is a factor? B. 7x minus 5. You have to be really careful, because not only is this a super difficult question, but look at this. This is 3x plus 4, and that says 3x minus 4. That's not the same thing. Okay, so just be really careful. All right, number 36. Which expression is equivalent to, what do? We store in 2 for the value of x. Oh, look, I have h as my variable. Well, you know what? Let's replace h with x on our calculator. Let's replace h with x on our calculator, and then just type in x squared plus 9x minus 1. You type it in exactly as you see it. The only thing we're doing is replacing h with x. What do we get when we press enter? Well, when 2 is stored in for the value of x, I get negative 105. So if I go through anything that still has 2 stored in for the value of x, when I plug it in, I'll get the same thing. That's what's equivalent. That's what's the same. And F is actually my answer, negative 105. So how I really like to teach this trinomial times this binomial so that nobody makes any mistakes or draw a grid, you can, what you just have to do is make sure every term in this trinomial gets multiplied by every term in this binomial. Okay, but I've basically got a trinomial, so 3 terms, times a binomial, 2 terms. Every term gets its own column or own row. And then we just start multiplying, okay? I'm going to multiply h squared times negative 4h. I get negative 4h cubed. 9h times negative 4h. Negative 1 times negative 4h. And I write what I get when I multiply all of those. And then I combine like terms, and I would get F. All right. Number 44, which expression is a factor of? Again, because we only have one factor, there's no trick. Okay? You just have to know how to factor. Okay. So this again is a slip and slide trinomial. I need to slip A into C by multiplying, and I get r squared minus 4r plus 9. I need two numbers that multiply to 9, add to negative 4. If I list my factors of 9, 1 times 9, 2 doesn't go into 9, 3 does, 3 times 3, and as soon as they start switching places, I know I'm done. So do any of these also add to negative 4? 1 plus 9 is 10, 3 plus 3 is 6. I can't factor it, and that's okay. There are no real factors. Now, if you have factors of a quadratic, when you graph this in y equals, it will cross the x-axis. If I graph this, y equals x, or I'm sorry, 9x squared minus 4x plus 1, if I graph this on my calculator, it doesn't cross the x-axis, so there won't be any real factors. Okay, let's go on to number 49. Number 49, which expression is equivalent to, oh my gosh, this is a big one. Okay, well, I've got two different variables, So let's store in 2 for Q, 3 for W, and then what I would suggest doing is, since you have like these two fractions here, right here, I would type in alpha y equals, and then press enter. Now this is on a TI 84. If you have an Inspire, you just enter it differently, or even an Inspire on the iPad, that does it differently. So enter, and then a lot of students really like that because it's like, it looks like this over this. So then you can literally type in exactly that on your home screen. Don't forget to arrow out after you type in 10q to the 5th w to the 7th over 2w cubed. Arrow out, that's that arrow like that, right? Arrow out, multiply, looks like that, and then do another alpha y equals, then enter for a fraction, and you'll get this. Okay, and then type in 4, open parentheses, q to the power of 6, arrow out, close parentheses, raised to the power of 2. Just make sure you're entering it in exactly as you see it, and that can sometimes get a little tricky. So when you enter that in, you get like 5.1597, yada, yada, yada. So when you plug in all these different answer choices, B is what will also give you 5.1597, yada, yada. All right, we've got one more problem from reporting category number 1 on the 2018 version. Lots of equivalence. Which expression is equivalent to? Well, I don't have a variable here, okay? So if I just type in the square root of 96, I get about, I'm going to do my little squigglies, 9.797 ... D is the only one when I also plug in, 4 times the square root of 6, I also get 9.797 ... So like if you plug in 8, like looking at this answer choice, 8 times the square root of 6, I'll get 19.595. So obviously that's not the same, so it's not going to be that one. Obviously it's not 24. Obviously it's not 48. So what you have to really be careful about in these situations is sometimes they'll give you an answer choice that's equivalent to, but it won't be the most simplified version. So if they ask you a question that's like, which, simplify this square root or this non-perfect square, it can just get a little tricky. So how I do this, if I want to simplify the square root of 96, the biggest perfect square that goes into 96 is 16. So the square root of 16 times the square root of 6. And then what is the square root of 16? It's 4. So 4 times the square root of 6 is 4 square roots of 6, or 4 root 6. So that's how I would do that. And that concludes your video over the 2018 version of the Algebra 1 EOC questions in reporting category number 1. Hope it was helpful.